Okay, so this hopefully will be the shortest video in the history of Mrs. Thomas videos. We just had a tiny bit that I really wanted to make sure that I pointed out. So we had just finished the definition for pictographs, which are a type of deceiving graph, and we'd written down the reason why that we're talking about one-dimensional data, and we are representing it with a picture that, by the nature of the picture, is two-dimensional or three-dimensional. So here was an example that I printed out from the book. This is a pictograph. So you've got the pictures of the cigarettes with the statistics underneath. So the statistic itself is probably fine. However, what happens, and of course, if you look at 18 and 37, 37 is approximately twice as much as 18. So when you look at just the statistics, you would say, okay, well, the amount of U.S. adults who smoke has been cut in about half. But what the problem is that because the cigarette pictures here are really, I mean, they have some shading, so they're kind of three-dimensional, but not really. They're more 2D than anything else. What they have done is they have made the length of the cigarette twice as much. You can see I'm estimating that with my fingers, and then also made the width twice as much. So I'm not super good at drawing anything, so excuse my poor rendition here. But I'm going to convert these to just like as if they were rectangles. So if I've got a rectangle, like so, and again, I'm just going to eyeball this, so forgive me if it's not exact, and I make its width about half, and I also make its length about half. What ends up happening is that if you read the actual statistic, you can see, oh yeah, half as much-ish. But when you actually look at the picture, most people, when you're looking at something that has two dimensions, automatically think about the size as in terms of area. So what happens here is, and now we're just talking about rectangles and not necessarily these cigarettes here, but let's say that this was 4 and this was 2, and so if that's for, let's say that this is about, I don't know, 12, which means this would be 6. The area of this rectangle is 48 square units. The area of this rectangle is 12 square units. So the problem with using something that is two-dimensional to represent a statistic, a data set that's one-dimensional, is that the picture actually looks, in this case, 4 times as big, when really the statistic, it's only twice as big. Now, as you can imagine, if we then were to take a three-dimensional object, it gets cubed. So if the actual difference is by 2, then in this model, it ends up being by 4 because 2 squared is 4. If I were to draw like rectangular prisms, out here and then continue that pattern where this depth is also, half as much, then now suddenly it's even worse because your eye is automatically then drawn to volume. And the volume here, if this were 2 and this were 1, let's say, so this was area, so this was square units for the area. The volume here, length times width times height, is 12 cubic units. Here we have 4 times 12 times 2. So what is that, 96? And so now suddenly the scale is increasing. It's off by a lot more. So this is why pictographs are bad, is the picture makes it seem like a bigger difference than it actually is. So I wanted you to understand the scale because that'll help you with the homework questions on those as to why, the graph is deceiving. What's wrong with it? So you can specifically say, because you've used two-dimensional, the statistic looks like it's twice as much, but the picture makes it look 4 times as big, something like that. All right, then the very last definition, non-zero vertical axis. So this isn't a type of graph that's deceiving. It's a way that even good graphs can be made to look deceiving. And make sure that you do the reading because they've got pictures to illustrate this in your text. So typically, enlightening graphs can become deceiving when a non-zero vertical axis is used. I put exception, break in a time series graph. So what I mean by that is if you have something like this on your vertical axis and you have a time series graph where you're literally just connecting, point to point, as long as everything was above the break, which you wouldn't put a break in if it weren't, then in this case, the non-zero vertical axis really wouldn't make a difference. So that's the exception to the rule. Other than that, anytime you use a non-zero vertical axis, meaning you try to start down here at 50 or something, then it's going to be a deceiving graph. All right, hopefully that makes sense. Good luck, and I will leave you homework keys to check things.